This is an analogy of why a representative sample is needed to make an accurate conclusion about an entire population. This cake right here is meant to be an entire population of food. The population of food has 3 layers in this case. It has a layer of icing, a layer of plain cake, and a layer of chocolate cake. We can see that each layer is a third of the cake. I want to take a sample of this cake so I can get an idea of what this cake tastes like. If I cut straight down, like this, then I'll end up with a sample that's 1/3 icing, 1/3 plain, and 1/3 chocolate, just like how the entire cake is 1/3 icing, 1/3 plain, and 1/3 chocolate. Since the fractions in my sample match the fractions in the entire population, my sample over here is representative. This sample right here is representative of the entire cake. And this sample right here would give me a very accurate idea of what the entire cake tastes like. After I eat the sample, I'll know that the cake is 1/3 icing, 1/3 plain, and 1/3 chocolate. So this is a representative sample, and it gives me highly accurate information about the entire population. What if I took a non-representative or a biased sample of the cake? What if I cut diagonally like this? And then this was my sample of the cake right here. This piece of cake right here obviously isn't a representative sample because it's more than 1/3 icing. It looks like it's probably more than 1/3 plain, and it's less than 1/3 chocolate. So the fractions in the sample don't match the fractions in the entire population. And since this sample of cake isn't representative, it's going to give me misleading information about the entire cake. It's going to make me think that the cake is mostly plain and mostly icing and not very much chocolate. So if I like chocolate, then this non-representative sample is going to make me think that the cake isn't very good when the cake is actually better than I think it is. This non-representative sample would lead me to a wrong conclusion about the entire cake.